Hello, let's look at problems from Module 11, sequences and series. So first one, write the first four terms of the following sequence. So pause the video, try on your own, then see if your work matches my work. So here b of n is given as -1 to the n power times n. So first term will be -1 to the 1 power times 1 gives me -1. Second term, -1 to second power times 2. This will be +1 times 2 gives me 2. B of 3, -1, 3 times 3. Third power times 3. This will be -1 times 3 gives me -3. Fourth power, this will be +1, so it'll be 4. So we have so far, you write in a bracket, -1, 2, -3, 4. Again, this will continue unless it says it's a finite sequence. And here, as you can see, the sign also changes, right? Negative, positive, negative, positive. And sometimes we call this kind of sequence a alternating sequence. So try B. Again, pause the video, try B on your own. And come back. So C of 1 will be -1 to second power times 1 over 1. Gives me +1. C of 2, -1 to the third power times 1 over 2. This will be -1, so it'll be -half. C of 3, -1 to fourth power, 1 over 3. This will be +1, so 1 over 3. C to the fourth, -1 to the fifth power, 1 over 4. This will be -1, so it'll be -1/4. So another alternating sequence, whereas in sign changes consecutively. Okay. So let's look at this one. Find the sum of each sequence. So here, when we have a third power or second power, right, in an equation, we have to use that sum formula. So before we do that, we need to split this into 3 different parts. K to the third minus 3, I'm going to take 3 outside here. K square, 5k to the 1, 1 to 5, plus 8, 5k equals 1. So again, the formula for each of these you don't have to memorize. But for this one, the third power is n times n plus 1. So it'll be n times n plus 1 over 2, entire thing square, minus 3 k square. The formula is n times n plus 1, n plus 2. Oops, 2n plus 1, sorry. 2n plus 1 over 6. Plus this one will be just constant, so it'll be 5 times 8. 5 times 8. So here, instead of n, we just need to plug in 5 since we're only adding 5 terms. So I'm just going to erase n, these parts, and replace with 5. So 5 plus 5 times 6, because it would be 5 plus 1. And it'll be 5 times 6 times 11. So let's simplify a little bit. This is 3. We have 15 squared minus 6's cancel out. We have 3 times, so it'll be 15 times 11 plus 40. Okay. So let's simplify. 15 times 15. Meet on the side here. 75, 15, 225. Okay. So we have 225 plus 15 times 11 is 165 plus 140. Okay. It would be 225 plus 205 gives us, oops, gives us 430. Okay, so that's the sum. Now let's look at part B. So part B has two ways of doing it. We can either split this into two sums like this, or we can recognize that this is a arithmetic sequence. So then find the first term, find the last term. So first term will be just 5. Last term will be 92. So then sum of 30 term in arithmetic sequence would be n over 2, which is 30 over 2 times 5 plus 92. Okay. So we have 15 times, this is 15, right? 97. And 15 times 97 is 1455. And if you do this way, you should get the same answer as well. Okay. But this is a little more fast. It's a little faster if we use arithmetic sum formula. Okay. Okay, number 3. Write out the first 5 terms of sequence given. Okay. Given the 5th term is 30 and 12th term is negative 12. Okay. So here what we have to do is first we need to write down the general formula for arithmetic sequence, which is an equals first term, which we don't know what it is, first term plus m minus 1d. Okay. But what we know is when it is 5, so when n is 5, we know that this formula, oops, n is 5, so I'm going to plug 5 here, equals 30. And when n is 12, we know that 12 minus 1 times d equals negative 12. So we're going to look at these two equations right here, and we're going to have systems of linear equation. So let's simplify this. We have first term plus 4d equals 30. First term plus 11d equals negative 12. So this, we have two equations, two unknowns, and in this case, two unknowns are first term and common difference. So here we can subtract, then we get negative 7d equals positive 42. So common difference is negative 6. Okay. So negative 6. So using this formula again, we know that so far we have a sub n equals first term plus m minus 1 times negative 6. But now using this, using this equation, or using one of these, we can also find the first term, right? So let me plug negative 6 here. Right, so then that gives me a sub 1 minus 26 equals 30. A sub 1 equals 56. So here we can write 56. Use different color. So let me simplify this. We have 56 minus 6n plus 6 equals 62 minus 6n. So this is the equation for the sequence, the formula for the sequence. So yeah, first 5 term you can find it, right? Just plug 1, 2, 3, 4, 5, right? But the main idea of this problem is coming up with this equation. Okay, so in terms of, if you think of a function, we have 2 points. We have 5, 30, and 12, -12, and that's what we did here using arithmetic sequence formula. Okay, so let's look at number 4. Number 4 just says find the sum. Okay, so how do we do that, right? So when we find the sum, first we have to recognize what kind of sequence it is. So here we can see that we're adding by 3, right? So this is arithmetic sequence. So for arithmetic sequence, we know that the formula is this one right here. So we can find the first term, and we know last term is given 299. But we don't know what n is. So we have to figure out what n is. So this is also nth term, the last term. So in order to figure this out, again, we have to use the arithmetic sequence equation. Okay, so we know that a sub n equals the first term plus n minus 1 times common difference, which is 3. Simplify 2 plus 3n minus 3 gives me -1 plus 3n. Okay, so this is the equation for the, remember an here. This is the equation for the arithmetic sequence. And we can test it. If you plug 1 in here, you get 2. If you plug 2 in, you get 5. If you plug 3, you get 8. So now what we do is, using this, we need to know what n is needed to get 299. Like this. So term number for 299. So solve for n, we'll get 300 equals 3n. N is 100. So here, this is 100th term, which means we're adding 100. We're adding 100 terms in a sequence. So s of 100 equals 100 over 2. First term was 2. Last term was 299. So let me simplify here. 50 times, what is that? 301. Okay. So that should be 15,000 and 50. Okay. So here, important part is first recognizing what sequence we're dealing with, so that we can identify formula we need to use to find the sum. Okay. But for this problem, we needed to find the nth term, not n, how many terms we're adding. That means we're finding the term number for this one. In order to do that, we have to come up with this equation. Then set 299 equal the equation to find the n. Okay. Number 5. Again, pause the video and try on your own. Okay. So it says, find the formula for a sub n for geometric sequence. So what is the common ratio here? So common ratio is 1/3 divided by 1, which is 1/3. 1 over 9 divided by 1/3, it's also 1/3. So common ratio is 1/3. So let's write r equals 1/3, or 1 over 3. An equation for geometric sequence is a sub n equals the first term times common ratio to n minus 1. So here first term is 1, so 1/3 n minus 1. So this is the formula for this geometric sequence right here. So to find 10th term, we just put 10 in. 9 power, which is 1 over 3 to the 9. And we can just leave it like this. 3 to 9 is a huge number. Okay. Okay. Now a similar problem, we saw this similar to this, but now they give a r mean common ratio. So first, again, let's come up with the equation. Since, so this should be actually geometric sequence. So common ratio is given, so we have to look at geometric sequence equation. So then nth term is first term times common ratio to n minus 1. Okay, so this is the formula. Now, you know, to write our first 5 terms, just plug 1 in. Well, it's 8. Second term will be 3 times, oops, not 3, 8 times 3, 24. Third term will be 8 times 3 to the second power, which is essentially 24 times 3, 72. A to the fourth will be 8 times 3 to the third power, which is 27 times 8 gives us 2, should be 216. Okay. That's the first 5 terms. Yeah, so a fifth would be a to the 3 to the fourth power, which is 648. Okay, let's look at number 7. It says find the sum of this sequence 3 plus 1 plus 1/3 plus dot 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 1 over 2187. So what kind of sequence is this? It is, we can find a common ratio of 1/3 because we're multiplying 1/3 every time here. This is a geometric sequence, right? And we're adding finite number of them, right? So we have to use geometric sequence formula, which is for finite one is S of n, first term, 1 minus Rn over 1 minus R. Okay. So we know what first term is, we know what ratio is, but we don't know term number for this. We don't know this yet. So we need to know how many we're adding. So what we do is A sub n, first come up with the generic formula for this sequence, which is 3 times 1/3 n minus 1. Okay. So then we need to set this equals to 1 over 2187. Okay, so it's solving exponential, right? So we can divide by 3 both sides, then we get 1, 3, n minus 1 equals 1 over. Then we do 2187 times 3. Since we're dividing by 3 both sides to put this out, we'll get rid of this, right? So 2187 times 3 gives me 6561. Okay. So here, there are 2 ways to solve for n right here. One is using log. Okay. But in order to do that, we need a calculator. Or specifically, we need a calculator that does log calculation. But here, this is simple enough. Simple as in, we can do enough guess and check to find the n. So using exponent rule, we have n1 to the n minus 1 power and 3 to n minus 1 power equals 1 over 6561. But we know that 1 to any power is 1. And we know n is a positive number, so this will give us a 1 regardless. So essentially, we're solving 3 to the n minus 1 power equals to 6561. So here we have to do some try and error, because if you do like 3 to the, for example, 8th power, so 3 to the 8th power will give us 6561. That means that n has to be 9, right? Because it's n minus 1. So going that backward step, it tells us that n is in fact 9. So if I plug 9 here at 9 minus 1 gives me 8. So 3 to the 8th power gives me 6561. So this tells us that n is 9. That means we're adding 9 things. This is 9th term. 9th term. So applying the formula, let me just write it here using this formula right here, this one. Our sum is 3 to the multiply 1 minus common ratio 1/3 to the 9th power over 1 minus 1/3. Okay. And this one, yeah, I don't require to simplify. That's fine. Okay. So that's fine as it is. Okay. For infinite sum, right, we should be able to simplify because it's a lot simpler formula. Okay. And you should be able to do this, right? It just takes time to simplify all the way down, because the main idea is just coming with using these equations, not necessarily doing just arithmetic calculations. Okay, so now let's look at this. Okay, so find the sum k to n and 4 over 5 to the k's power. So here they're not actually telling us specific n, just in general, right? So then we have to recognize this is a geometric sequence, so we have to use this formula again. So what's the first term? Here we plug 1 in, then we'll get 4 over 5. So the first term is 4 over 5. So sometimes for geometric sequence, instead of k minus 1, we use k. Okay, but regardless, we can recognize common ratio, and that's how we can identify this is a geometric sequence. Okay. So then S of n, it will be 4 over 5, 1 minus 4 over 5 to n power over 1 minus 4 over 5. So this one we can simplify. 4 over 5, 1 minus 4 over 5 to the n. This right here, this part right here will be 5 over 5, so it'll be 1 over 5. So we can, since we're dividing, we can multiply by reciprocal, so we can write it like this. 5 over 1 times 1 minus 4 over 5 to the n power. So 5's cancel out. So let me go up and write the final answer. Will be 4 times 1 minus 4 over 5 to the nth power. So this is a simplified version of finding this sum. So whatever n is, if we're adding 10 of them, put 10 in n right here. If we're adding 1,000 terms, put 1,000 right there. Okay, let's look at number 9. Okay, so determine whether the infinite geometric series converges or diverges. If it converges, find the sum. So first of all, let's find the common ratio, which is just 249 over 343, which gives us 1 over 7. And 7 over 49 also gives us 1 over 7. So common ratio is 1 over 7. And absolute value of 1 over 7 is less than 1. So again, we always have to check that rule, because if this is the case, then we can find infinite sum for geometric sequence. Yes. So then it converges, and it converges to what? We'll use this formula. First term over 1 minus r. So first term is 343 over 1 minus 1 over 7, which is 343 over 6 over 7. Then we can simplify to 7 over 6 times 343. And 7 times 343 gives me 2401 over 6. And this is as simple as we can write in fraction. Okay. So final answer, it converges to this number right here. If common ratio, if this didn't satisfy, if common ratio was like 7 or just 5 or even 3 over 2, -5, -10, any of those number, if you had any of those number for common ratio, you would diverge. That means sum does not exist. Okay. Similar problem. Determine whether the infinite geometric series converges or diverges. So here common ratio is -12. And absolute value of r is less than 1. So because absolute value in this case will be half, right? So this means, yeah, we can use this formula. So again, always check this before you write this formula down. Okay. So what is the first term? First term here is 8 over 1 minus -12, which is 8 over 1 plus 1 over 2. 8 over 3 over 2 is 8 times 2 over 3, which is 16 over 3. Okay. So remember, adding infinite number of things is only possible for geometric sequence when common ratio, absolute value of common ratio is less than 1. Okay. And hopefully this makes intuitive sense, right? So let me, well, this is the end of the problem, but let me give kind of additional explanation here. When we add, like for example, 2 plus 4 plus, this is 6 plus 8 plus 10 plus, we'll keep adding, right? So this goes to positive infinity because we keep adding bigger number. And same thing for even if we subtract, if for arithmetic sequence, right? What when I subtract 30 every time, right? Well, we're adding negative number. That's how we can think about it. Well, same thing subtracting. So let's keep it like this: -10, ... This will go towards negative infinity. So it doesn't make sense that we can add infinite number of things or subtract infinite number of things and get a number for arithmetic sequence, right? And same thing for geometric sequence that is increasing. So for geometric sequence, maybe you can think as 4, let's say triples. No, I think double is fine. So 8, 16, 32, right? If you add these, right, we'll keep adding bigger and bigger number. So again, this will go towards infinity, right? But if common ratio, for example, I know I kind of briefly explained this in the first video. If I do half plus 1/4 plus 1/8 plus 1/16, right? This go towards a number, right? So let me explain this with a picture. So if I have a square, right, and let's say this length is 1 and 1, we can represent half as, okay, half of this square, right? And because area of this square is 1, right? So this is half. 1/4 is right here. Here's 1/8. Here's 1/16. Here's 1/3 over 32. See, we'll keep this process forever. And if we add all of them, we get 1, right? And of course, this picture is easier to draw for this case, right? But essentially, that's what's happening here even for this problem right here, right? We keep adding smaller number, but we can add all infinite numbers up to, and all those number when we add, it converges to a certain number. So this one, yeah, converges to 1. In this case, it converges to 16 over 3.